Okay, so you watched the video and you saw a little bit about what is compound interest. Pretty much just earning money or earning interest on top of your interest. Over here on the left, I have the formulas, so go ahead and pause the video and write that down. It says P is equal to the principal amount, or our beginning amount, starting amount. R is my rate. N is the number of times it's compounding per year, and T is the time. So when I look at number 5, it says Connor earned $4,000 working at McDonald's. He invested $2,500 from his earnings into a savings account, earning 2.25% annual interest. If he makes no other deposits or withdrawal, find his account balance after 15 years if the interest is compounded with the following frequencies. So the thing is that he's earning 2.25 annual interest, but it's still being compounded so many times per year. We're going to calculate with it compounded one time per year. Semi-annually, that means it's going to be 2 times per year. Quarterly is going to compound 4 times per year. And monthly means there's 12 months in a year, so it's going to be 12 times per year. And I'm doing this on my iPad and it's not cooperating. So we're going to figure out when Connor deposits or puts $2,500 in his account, how much is he going to have after 15 years? So the first one is annual. I'm going to just plug everything into my formula. So my amount is equal to my principal amount, which is $2,500, times 1 plus my rate is 2.25, which means I need to change it to a decimal. So that'll be 0.0225 divided by the number of times it's compounded per year. In this case, it's going to be 1. I don't have to write the 1, but just for the sake of using the formula, I'm going to put it there. And then my power is 1 time per year. So that's 1 times 15 for 15 years. So let me simplify this a little bit. That'll be 2,500 times, and when I add these together, I get 1.0225 to the 15th power. Go ahead and plug that in your calculator, and the amount that Connor will have after 15 years, you should get, we're talking about dollars, it'll be $3,490.52. Okay, so now let's go ahead and look at it semi-annually. That's twice per year. So use my amount is equal to the same $2,500 investment times 1 plus the same interest rate, 0.0225, divided by, and N is the number of times per year. This time it's 2 times per year. And it's going to be raised to 2 times a year over 15 years. I get all these stray marks on here. So let me simplify that a little bit. My amount is going to equal to $2,500 times. Now, if I can add this inside into my calculator, it should say 1.01125 to the 30th power. Now put that string in your calculator, and you can pause it as you need to, but when you do, our amount will be $3,497.00. Okay, so you can already see the differences. Once a year, $3,490, and then twice a year, $3,497. So you earn more money the more it's compounded. Okay, let's do the next one. We're going to compound it quarterly. So my amount is equal to a $2,500 investment times 1 plus my interest rate, 0.0225, divided by the number of times per year. In this case, it's going to be 4. Raised to my power of the number of times is compounded over 15 years. And it's good to try to simplify it a little bit, because if you try to put this whole thing in the calculator as your powers increase, it is really going to leave room for error. So I have $2,500 times, and I'll go ahead and add these values here first. So that's 1.005625 raised to the 60th power. Now it's a little bit easier to go ahead and put this string in your calculator. And when you do that, your amount should equal $3,500.29. Okay. And lastly, we're going to find it with him having it compounded monthly. So my amount is equal to $2,500 invested times the quantity of 1 plus 0.0225 over monthly, mean it's going to be compounded 12 times per year, raised to 12 times per year over 15 years. So again, I'm going to clean this up a little bit. So make sure you guys are checking in your calculator too, because you know I can make mistakes. So add this up, and I got 1.001875, and then 12 times 50 is 180, raised to the 180th power. Okay, so go ahead and put this string in your calculator. And when I do, my amount that I get is $3,502.49. So that's how much he'll earn over a $2,500 investment if it's compounded annually, monthly. I'm sorry, let me take that off. Annually, semi-annually, quarterly, and monthly. Okay? So sometimes you have interest that's not being compounded a certain number of times per month, per year. You actually have what's called continuous compound interest. And that means that your interest is actually earning or being compounded on a continuous basis. This formula is very similar to the continuous growth formula. And that formula is my amount is equal to my principal amount times e to the RT power. P is still my principal amount. R is my rate. And T is over time. Again, it's compounding continuously, so there's no end, a number of times per month. So number 6, it says find the balance of an account after 5 years if $1,200 is invested at an interest rate of 12.5% per year, compounded continuously, and there are no other deposits or withdrawal. So my amount of time is 5 years. And my initial investment is $1,200. So when I plug this into the formula, then I have my amount is equal to 1,200 times E, and that's your irrational number E. So 1,200 E to the 12%, so 0.125 over 5 years. I get all these weird stray marks. Okay, so put this string in your calculator, and when you do for your amount, I should have, let me clean this up some, 1,200 e to the 0.625 power, and that's going to give me approximately $2,241.90. Okay, so that's your continuous compound. And then lastly, you've got Jordan invested $1,500 in a 30-year retirement account. So that's going to be my time. Determine which of the interest rates and compounding periods will give is his best investment plan. So you are going to calculate it using option A with an annual interest compounded monthly, and option B with an annual interest compound continuously. I want you to do this, and when I come back, I'm going to ask you which of